with the judges. So let's call on our first startup from Carnot.
So I'm Francis Lempp, one of the co-founders of Carno, a startup developing technologies at the very heart of sustainable powertrains. And so Carno was formed to tackle one of the toughest challenges of net zero right now, which is trying to decarbonize the hardest to abate sectors, things like marine, heavy-duty vehicles, and prime power, currently responsible for about 13% of global CO2, and more worryingly, with no production-ready solutions to actually achieve net zero. So what are some of the options for these markets? And the traditional lineup starts with conventional engine technology, which despite great range, power density, and total cost of ownership, is the emissions at the very source of the problem we're trying to solve. And so next on the list is batteries, and they do solve the emissions problem. And don't get me wrong, they are great for light duty, short range applications. But for these markets, the size and power requirements often mean that they're too costly, heavy, difficult to recharge, and ultimately result in unaffordable total cost of ownership for end users. Fuel cells are facing very similar problems, and actually for all hydrogen-only technologies, there's the additional problem of how expensive green hydrogen is and the infrastructure required to make it happen. And so at Carno, we believe that the best solution for these markets is a clean and efficient engine. And we think we can provide a solution to this with the world's most efficient net zero fuel agnostic powertrain, which granted is a bit of a mouthful, so let me try and break that up. And at the core of the technology is using advanced technical ceramics and super alloys to eliminate the need for traditional engine cooling systems, which are the biggest driver of inefficiencies and emissions in modern engines. But we didn't stop there. We actually designed the entire engine architecture to be completely fuel agnostic, meaning it can not only run on hydrogen, but also biofuels, e-fuels, ammonia, and blends of these different fuels as well, with a simple, easy to replace modular fuel delivery system. And so let's talk about the stage of this technology today. And alongside a proof of concept prototype, we've also formed 2 industry-funded co-development projects in shipping and mining to deliver demonstrator solutions. And we found that when operating on a hydrogen and ammonia blend, we were actually more affordable than traditional diesel, saving about 17,000 tons of CO2 per engine over the course of its life, with NOx emissions being completely negligible and ultimately zero, making us a truly zero emission combustion solution. And so looking forward, ultimately, we want to be a powertrain supplier and partner with the existing industry to tap into the existing manufacturing and capacity and supply chains that already exist for engines, targeting initially low barrier applications like static power generation and auxiliary power units before moving into main propulsion systems. And so I'd just like to finish on our major industry, academic, and government backing that includes people like Oxford University, Fraunhofer IKTS, which are the world's leading research institute in ceramics, and of course a well-built team with expertise in Formula One, aerospace, through to startup commercialization as well. So thank you very much, and look forward to any questions.
Thank you so much. So judges, you have the stage now. Who would like to start?
Yeah, quick question. I'm interested in, I suppose, how you're going to take it through to commercialization. You talked a little bit about partnering with the existing supply chain. What does that part of the journey look like for you?
Great question. And ultimately, with hardware, there's sort of 2 options. You go down IP licensing, or you do the manufacturing yourself. And IP licensing de-risks the manufacturing, but ultimately gives you less of the whole value chain as a company. Manufacturing has significant risks. Design for manufacturing cost is an entirely different skill set to innovating. And so what we want to do is essentially partner with the existing suppliers. They know how to scale, they know how to design for cost, and ultimately go down the contract manufacturing route that should give us an ability to scale as rapidly as possible while retaining a good portion of the value chain.
Awesome. I would like to ask a question about the team. So can you talk a bit about the team structure, what everybody does?
Yeah, another great question. Thank you. And ultimately, on the engineering side, we go for a Formula One derived team because they're used to very, very quick timelines, pace of development. they're multidisciplinary, so we're not kind of bottlenecked into waiting for one department to kind of finish up simulations or testing. And as we look forward, what we want to do is expand our business side of things. So looking into companies that can better demonstrate our value to end users, and expand the engineering team. We take special effort to look at making sure that we are as kind of diverse as possible. We know that adds a lot of value to your ability to innovate. So especially looking for females in engineering, people of different backgrounds as well, that ultimately foster into a better team.
Yeah, I'd like to drill down on that kind of one level deeper as well. How big is the team now, and what are you hoping to scale the team to with the next round of investment?
So at the moment, we're 9 full-time equivalent employees. With the next round of investments, the Series A we're raising now to actually deliver field trials, we want to scale to, in the first year, 16 full-time equivalent employees, and then up to 26 after that. Mainly building more competency in the engineering, but as I said, slowly expanding our commercial capability alongside that.
I have a question regarding your competitive landscape. Do you have any competitors, and what makes you unique?
So we see our main competitors being fuel cells and batteries. And as I described, often it comes down to the argument of total cost of ownership for these more commercial markets where they have to make a decision to go to net zero, which also doesn't impact their kind of margins. On the engine space, there are not a lot of people really that can offer our step change in efficiency. So combustion engines are still being developed to be net zero, but ultimately it's our ability to remove the cooling system with advanced technical ceramics that give us a step change efficiency that no one else has managed to achieve, and which is about twice the kind of modern standard of combustion engine efficiency.
Okay, thanks.
Thank you so much, Carno.
Thank you.